Welcome everybody to this Digital Intergeo 2020. I am Martina Di Rito, a product engineer working in the Lag Infinity software team and taking care for all the imaging related functionalities in Infinity. My presentation will be about how to unlock even more capabilities from the GS18 I RTK rover using Lag Infinity. A technical comment before starting: at any time during the presentation you can ask your questions in the chat box, and after the presentation, I will answer them in the Q&A session. Let's get started. As my colleagues explained in more details in other presentations, GS18 I is the new Leica RTK rover, which integrates GNSS, inertial measurement, and a camera to offer visual position technology. Infinity fully supports the GS18 I, expanding its functionalities. Today, I will show you how to work with GS18 I data in the office and why, explaining the advantages of expanding the workflow in the office with Infinity. You will know more about reviewing points measured in the field, measure new points in the office, and generate point clouds. But before jumping into Infinity and how to work with GS18 I data, I want to spend a few words explaining something very easy and very important at the same time. GS18 I is a new great solution for surveyors. It gives you the possibility to acquire GNSS points, measure points for images on site and in the office, and even generate a point cloud, all with the same rover. Still, it is important to remember that this is not as a scanner. Because GS18 I is based on photogrammetry, the expected accuracy of the point cloud will not be on millimeter level, but on centimeter level. On the other hand, everything you get with your data is already georeferenced. So I guess you already got my point. GS18 I is a complementary solution, and Infinity is the place where you can combine data coming from all these devices. Before demonstrating how to work with GS18 I in the office, I want to show how easy it is to get into Infinity your field data ready to work. I will explain you this in the following short demo. Open the application, go to the File menu, select a new project, and give your project a name. Here, you can also select your preferred display units, create your own project template, and do other useful things to properly set up your project. Then, click Create. Import is as easy as usual. In the Home ribbon bar, click the Import button, browse to the required location, select the DBX file, and click on Import. For those who are not new with Infinity, these first steps might look trivial, but believe me, in a while I will show you how easily all the data captured in field jobs can be imported and are usable in Infinity projects. And here you are, your captured data. All the images and points acquired are visualized. Using a base map, like in my case, you can also have a stronger visual awareness of the work done in the field and have a better representation of where your data are. Imported file is listed in the source, showing the image groups, the image points, and when there are GNSS points collected in the field, to always guarantee traceability of what is acquired. The image groups created in Captivate are then ready to work with in Infinity. Coordinate system used in the field is also imported and used in Infinity. In the library, all the objects connected to the acquired data are created and listed, points, and image groups. In the graphical view, you can visualize and navigate in the imported data. For now, I'll turn the base map off, clicking here. The view can be rotated, you can zoom in and out. Also, you can make images visible in the 3D view using the Layer Manager. Select the image Frussum, Layer, and turn it on. To see even in more detail what you captured in the images. So now we know how to import and visualize GS18 I data. Let's have a look at what we can do with this data in Infinity. So we can work with image points, reviewing field points and computing new points from images. And with Infinity, you can also expand on field capabilities and generate point clouds and merge image groups. I will show you how to do that in the next demo. You have imported GS18 I data and you want to review acquired points. How can this be done? Let's imagine that we want to check point right bottom window in image group 4. You can select the image group containing it, either from the inspector, the library, or the source. Open the image group viewer and go to the point table to check its position or coordinates quality, for example. If needed, this point can also be edited, adding or removing image observations. I will show you later how. Second step is measuring new points. In Infinity, you can perform a virtual survey, measuring new points from imported images, saving so expensive on-site time, and taking advantage of the office environment and large working display. How to do that? First, you have to identify the image group you want to work with. I know that the point I want to measure is in this area. So I select an image, check its image group from property grid. In this case, it's image group 3. Select it either from source, library, or inspector, and open the image group viewer. Navigate to the image of interest, either scrolling with the mouse, using the scroll bar, or typing an image name in the searching box. I want to measure this point, which can be acquired with classical GNSS techniques. Just right-click with the mouse, new point, done. Point is created. Quite fast, right? If you want, you can also add a code to the point from here, using an imported code table. I will use this one. And also assign a unique ID to the point. Click Create to store the point. Once the point is stored, it is added in the graphical view, in the inspector, in the library, in the point table, and in the image windows. Not in the source, which contains only data acquired in the field. When you select a point, images used for point computation are highlighted in light orange in the image strip, and point is shown in the images. In most cases, a single click defines the point. For the other cases, the classical manual point creation mode is still available. For those who were already using Infinity to create image points from TPS images, you'll notice that the image group viewer has been completely restructured, and more tools have been added to make more efficient and easy working with image data. From here, you can set the number of working windows. Also, when a point is selected, you can filter images to display, choosing between showing only images where points and projections exist, like in this case, or only images used for point computation. To avoid zooming in and out, a magnifier is available to help select features of interest and see pixel level details. You turn it on clicking here, and then create points as usual. Right click, new point, and clicking create. Under the working windows, there is the point table, listing any points computed in the field or in the office, which can be closed and opened from here to make it easier to view and work with image data. Same can be done with the image strip using this arrow. This was an overview about computing points from images. Let's now address the merge image groups topic. We know that GS18 I has a limit of 60 seconds per acquisition. That's why you will likely end up with many image groups in your field job, just like me in this case. It might happen though that the object you are interested in has been captured in multiple image groups, and you want to combine those together. Don't worry, this can be done in Infinity. Let's consider this building, which has been acquired by many images. If I don't remember what I did in the field, or if I was not the person who acquired data, I can select the images from the view to see which image groups they belong to, and then merge those together. This is image group 6, and this is image group 5. So we want to combine image groups 5 and 6 together. I select image group 5. I could do the same using image group 6. Right-click, merge to image group, and I choose the target image group from the list, which in this case is image group 6. In this way, image group 5 doesn't exist anymore, and all the images and on the points contained in the two image groups are now combined in image group 6. Merging image groups is useful both for point computation and point cloud generation. I will help you get a deeper understanding of that later in my presentation. Let's now tackle the last topic of this demo, point cloud generation. You can use Infinity to further expand your workflow and generate point clouds from GS18 I images. To generate a point cloud, you have to select the image group and press Dense Point Cloud either from Context menu or from the imaging ribbon bar. There's no need to run the orientation step since images are already oriented in the field. I am now running the process with default settings. You can change those selecting settings from the Imaging tab. Here the processing resolution can be defined. Also, when needed, you can change from here the filtering threshold and the minimum number of matches per point to generate a clean and complete result. A task has been submitted to the processing engine. It can be viewed in the Inspector, Imaging, Imaging Results. Once the task is completed, it is moved to the upper pane of the Results section. To accept the result, select the task and click Store. A new Dense Point Cloud object is added to the navigator in the Image Group node and in the Point Clouds node. Navigate then to the graphical view to visualize the Dense Point Cloud. To do so, use the visibility eyes in the navigator to turn off the other image groups. I will also turn off the base map. You can now rotate and zoom to visualize the point cloud generated from GS18 I images. Since points have been generated also out of the area of interest, we are going to change the point cloud settings to update the results. We go to the imaging ribbon bar, settings, and we set the filtering threshold to 5 centimeters. And we press OK. Then we select the image group and we use the filter dense point cloud functionality, which will just update the point cloud generated. Then we go to the Inspector, Imaging, Imaging Results, and we store the new result for the dense point cloud. And that's the updated point cloud, clean and complete. I want now to show you the added value created when using two complementary tools like GS18 I and UAV, for instance. I will import a point cloud I have previously generated from a dataset acquired with a drone over the same area. And that's the combined view. See how well they complement each other, how the aerial acquisition adds details to the terrestrial one, and vice versa. What I also would like you to focus on here is the added value created when using two complementary tools, processed and visualized in the same software environment. And the fact that GS18 I can be a complementary tool for one of your already existing daily workflows. So I guess I mentioned some new concepts for you in the last demo. That's why I want to take the time to go into more details about some of them. The first one is image groups merging. I have already shown you how to do that, but when does it make sense to merge image groups? So it can be done when image groups you want to merge have an overlap or they represent a common area, like in this picture, where the top row of images belongs to an image group and the second one belongs to a different image groups. Still, they represent the same area, a common area. Merging provides a better coverage, which would have a positive effect both when computing points from images and when generating a point cloud. In fact, as regards measuring points from images, merging image groups gives the possibility to add manual markings from different viewpoints, making the ray intersections more robust and point position even more accurate. Like in this case, merging image group green and image group blue, you can add markings on images with very different point of view, which helps when it comes to point position accuracy. As regards point cloud generation, creating a point cloud out of multiple image groups allows to create a more coherent 3D model of a bigger area, like in the example we saw already in the demo, showing a point cloud of a long building generated out of multiple image groups, out of 2 image groups in that case. Second focus point is about point cloud generation. In the same way as there are best practices to acquire images to create accurate image points, there are best practices about how to collect and process data to get the best point cloud out of GS18 I. Here the point is that we have a new exciting instrument in our hands, but we have to understand how to use it in the best way. First point, make sure to collect the data properly in the first place, so capturing images on the whole object of interest. If your target is, for example, this trench, you must walk on both sides to model it in a point cloud. Second point, make sure you walk at a steady, not too fast, not too slow pace to ensure good overlap. In fact, both extreme scenarios of not enough overlap and many images acquired too close each other produce low quality point clouds. In this case, the acquisition was so good that even the surveyor has been reconstructed in the point cloud. Make also sure that the object you want to generate the point cloud of is close enough to the GS18 I camera. If you want a really good point cloud, 2-4 meters is the optimal range. The farther the distance, the more the noise. Make also sure that lighting conditions are good during the entire acquisition and that you don't have, for example, sun reflection directly into the camera, like in the image on the right. In fact, this would cause some issues to the matching algorithm because the ray appears in the images intersecting different parts of the building, like you can see in the image strip. In the first image, it is above the right window. In the last, the ray is above the left window. A similar issue might be caused by rolling clouds. So here, to summarize, it's very important to check the same objects are not affected by changing lighting conditions over the acquisition. Now, so after best practices to acquire GS18 I data and get the best point cloud, last focus point is about best practices for processing images and get the best point cloud. As we saw in the demo, apart from processing resolution, these two are the crucial settings for point cloud generation, so filtering threshold and minimum number of matches per point. See this image where 10 centimeters of filtering threshold and 5 images as minimum matches have been set. That's what you get, just changing them to 5 centimeters and 10 images. See how the noise on the roof is gone? So it's a better result for sure. It's clear how these settings have then quite an influence on the quality of your final result. Important is that, as I've shown you in the demo, you don't have to process the point cloud again. You already have it. You just update the settings, use the filter point cloud functionality, and get an update point cloud in a few seconds. After that, you can even choose to automatically clean points. Infinity is able to identify and remove points outside the main area of interest. And voila. This is like, it looks like same data after just a couple of steps. So your clean, geometrically correct, and accurate point cloud is generated just following easy best practices. So this was about getting the most from GS18 I images in Infinity. But don't forget that Infinity also means connected and integrated solution. So this is the place where you can put everything together to expand even more GS18 I capabilities. For instance, combining it with other instruments and creating new workflows, like in the example I've shown you with GS18 I and UAV images. With this, we come to the end of my presentation. Thank you for listening. I hope you enjoyed it. And it's now time to answer your questions.